Here goes all about triangle. In this digital math notebook by Ms. Nong, I'm showing you all topics I could think of related to triangles. We start off with the content page, two green arrows. The first one is on any kind of triangle. We started off with classifying the triangle, and remember this part, there are different triangles in here, including right triangle. In the second part, the later part, we're going to focus on the right triangles, and we start off with Pythagorean theorem, the Pythagorean triples, special right triangles, and finally we are going to finish with trigonometry. In this video, students apply the Pythagorean theorem or its converse and work on problem solving to find the missing side length of a triangle. Student will also know the Pythagorean triples. If you happen to forget what postulate, axiom, or theorem means, please watch the video called Language of Geometry made by me earlier in the year. And in that video, we distinguish the difference between the three words for you: postulate, axiom, and theorem. Let's make sure that you can say the word Pythagorean. Say it after me. Pythagorean. Good. Let's say it together. Pythagorean theorem. Good. Pythagorean triples. Excellent. Pythagoras is a Greek mathematician in the 500 BC, and there's just one interesting fact I want to share with you. Well, he's the first one to prove, that's why the theorem bear his name, Pythagorean theorems. Pythagoras was not the first one who understood the relationship regarding the size of a right triangle nearly 1,000 years before Pythagoras. Three of the most common Pythagorean triples are 3, 4, 5, 5, 12, 13, and 8, 15, 17. I actually only remember the first set, 3, 4, 5. We will prove it to you in the next slide. There are two conditions that you must have to have Pythagorean triple. The first one is the three number must be positive integers that satisfy the Pythagorean theorems. The second condition is that you must have whole numbers. And by whole number, you have to be flexible. 3, 4, 5 are whole numbers. Square root of 100 is also a whole number. Even though it's a square root of 100, if you simplify, you still get 10 whole number. But the non-example we give you right here is the square root of 95. When you simplify, you cannot get a whole number like 10 or 9 or 5. You are going to get a decimal if you put that square root in the calculator. So that is a non-example of Pythagorean triples or whole numbers. Pythagorean triples, here are the set of the most common ones. Why they work, look at the last columns. Both sides is true when we plug in the numbers into Pythagorean theorems. In your notes, in Canvas class, we put Pythagorean triple, a set of three whole numbers that work in Pythagorean theorems. And we said the easiest way to get another Pythagorean triples is to scale it up, and we do that by just multiply all of the number by a common factors. We give you the example of 3, 4, 5, the common factor. We multiply 4, 5 by number 2, which is the common factor there, and we get 6, 8, 10 when we do that. You can go ahead and plug it into the Pythagorean theorems, and we show you an example of that right here. We substitute it in and we get 100 to be equal to 100 on the right side. So that's why we know that this set 6, 8, and 10 will work as a Pythagorean triple. You also have flashcards related to Pythagorean triples. Here you are seeing a few questions that we picked out from your Check for Understanding on the quiz on Pythagorean theorem and Pythagorean triples. Questions 25, 60, 65 is reduced to which Pythagorean triples? So what can they be reduced by? 5. So 5 going to 25 5 times. And I see only the first choice right here with 5 and the second one eliminate the bottom two by educated guess. You're down to 50-50 chance of getting it right. What else can we reduce 5? Divide 5 into 60, we also get 12. So 12 is the next number. And if I'm selecting an answer to be correct right here, I can go ahead and stop with number 12. But we can also double check with the last one. A very common question you might see on the check for understanding. We're just asking you to find the hypotenuse, the longest side here. You know that it is a right triangle. You can go ahead and use the Pythagorean theorem and find the hypotenuse. Another common question that you might get on the check for understanding here, you don't see any drawing. So I would strongly recommend that you draw as soon as you see this right triangle. You do not have to make sure that you have a rulers. Just make sure that you draw a rough draft of the right triangle and label it. If one of the leg is 15, hypotenuse is 17. You know the hypotenuse is always across or opposite. So a picture is worth 1,000 words. When you see this type of problems, make sure that you draw a rough draft and label all the information given to you. If you are just staring at the word and you don't draw this picture, it's going to be tough to answer these questions. So that's what we're looking for. One of the leg, hypotenuse, the longest side must be in. Number 15, doesn't matter which side you're putting it on, the short or the long side, it's okay. You may use both Pythagorean, which start with a squared plus b squared, or you may use the converse of Pythagorean theorems, and most of the time you will see that Miss Nong start with the converse with the longest side. Preference, you can use the a squared plus b squared first. There, that has to be in for the C. A and B can get 15, it doesn't matter which one. I put in 17 squared equal 15 squared plus x squared. The side I'm looking for is the x there. And you may use a scientific calculator or just a simple calculator. If you don't have this key right here for x squared, you may just go ahead and use 17, multiply 17 if you don't have that key, okay? And you are going to get 289. Solving for x, or I'm going to eliminate everything with the x. I'm going to go ahead and subtract 225 to both sides. I get 64 equal x squared, and I know I'm running out of room on the bottom right there. So I wrote x squared equals 64 on this side. One last step to do. Anytime you have x squared, you will get x just by taking the opposite of square, which is square root both sides. At this point, I hope you will remember 8 times 8 is 64. The answer for our x right here is 8, which is maybe choice D. What is the use of Pythagorean theorems? There are so many uses that you are going to see in real life application. Here's a website all on Pythagorean theorem. You can see it's used in architecture and construction, laying out squares, angles, navigation, surveying. You may check out more on this website. We are showing you just a few examples in this video. I also will show you a video. It's called Applying the Pythagorean Theorem. Made by Planet Nutshell.
The Pythagorean theorem helps people solve real-world problems. Lucy usually bikes to the park along Maple Avenue, then up Silver Street. Is Canyon Trail shorter? She knows the two legs, Maple Avenue and Silver Street, are 3 and 4 miles long. Applying the Pythagorean theorem, 3 squared plus 4 squared equals 25. She knows that 5 squared is 25, so the hypotenuse, the length of Canyon Trail, is 5 miles. 2 miles less of biking for Lucy. What if Lucy doesn't know the lengths of Maple Avenue and Silver Street? A coordinate plane can help. Lucy's house and the park can be points on the plane. One at 5, 1, and the other at 2, 5. To find the distance between A and B using the Pythagorean theorem, she needs a right triangle. One way to make one is to go 3 spaces left and 4 spaces up. For the horizontal leg, take the x distance of A and subtract the x distance of B. This is equivalent to subtracting the x coordinates of A and B. For the vertical leg, take the y distance of A and subtract the y distance of B. This is equivalent to subtracting the y coordinates of A and B. Now apply the Pythagorean theorem. 4 squared plus 3 squared is equal to 16 plus 9, which when added together equals 25. That's the same as 5 squared. Again, the length of Canyon Trail is 5 miles. If you can represent a problem using a right triangle, the Pythagorean theorem can help you find distances.
On this practice page, we have a lot more that use the Pythagorean theorem to find a missing side. So we will go ahead and begin looking at the top right hand corner right here, a short cartoon to take your eyes away from the work just for a moment. Why is the obtuse triangle always upset? The red triangle said, because it is never right. That's what the yellow one said. Oh, how cute. I want to remind you of the bottom portion. We have right here, the bottom portion is the self-check part. Fill in the letter as you're working so that we can make sure we're on the right track. Let's go ahead and begin with the Pythagorean theorems. Don't be scared when you see square root. It's fun once you know the rule. Remember, hypotenuse is always the longest side that we have. And it's always across from the right angle. In a right triangle, the sum of the squares of the legs is equal to the square of the hypotenuse. You see the Pythagorean theorem, or mathematically correct, because we are starting with the longest leg, C first, is called converse of the Pythagorean theorems. We are using the example on the right hand side, of purple, and you can see we are given the hypotenuse. It's the longest side right across from the right angle here. So that's the letter C. We must put it in correctly. Number 6 can be substituted for A or B. It doesn't matter. We are substituted in. We got 9 squared equals 6 squared plus B squared. I strongly recommend using the letter X variable for, the missing side that we're looking for. Why? Because you can see the letter B can be easily mistaken for 6 squared. And when that happens, when we misread our own handwriting or we misread the B for 6, you're going to end up with something strange, which is going to be confusing. We are going to simplify this top equation here. We get 9 squared, which is 9 times 9, 81. 6 squared, 6 times 6, 36. The variable, we just bring it down, B squared. Now I'm going to subtract both sides by 36 so I can isolate the B and solve for the letter B. I get B squared and subtract 36 from both sides. The right side cancel. The left side, subtract 36 from 81. I get 45. One more step and we're done. Square root both sides and I can take out the B because B squared, square root cancel out the square. And I end up with the left hand side square root of 45. I get 9 times 5 to be 4. Perfect square in the square root of 9, we get 3. Pull that out of the radical or square root sign, another name for radical. And double check the answer. You can double check by just using the number outside of the square root here. Multiply itself. 3 times 3, that give me 9. 9 times 5 give me 45. Your answer for 3 square root of 5, when you double check, you should get back to square root of 45. Solve for the missing side. Use the answer code to find the special name for 3 integers whose lengths form a right triangle. Tips: a 3, 4, 5 triangle has a leg to hypotenuse ratio of 3, 4, 5. If you can spot multiples of these numbers, you can solve those problems easily. All right. I think I already got the answer for the first one. Did you see it? Yes, part of the tip right here. This is the most basic right triangle, 3, 4, 5. And here on the A, if you did not read the tip, you would have solved by, substitute 5 for the letter C, 4, and then X for the missing side, and waste all the time to do the work. But look, here's the answer. We already know that this missing side is a 3. That's so quick because I read my tip and I didn't skip the small writing. The answer is only true if I see it down here, and I do see it right here. Oops. We don't have the number 1, 2, 3, we just have letters. The number A is solved. We're done. The letter E is the next one, 9, 12. And what is the missing number here? Remember, we are using the X for missing side. This is the hypotenuse letter C. We substituted in. I have C square started, so that become X square. I have 9 square and plus 12 square. So that can be the letter A and then letter B, or you can have 12 square plus 9 square. X square is going to stay the same. Try to line up your equal sign. 9 times 9 is 81 plus 12 times 12, I get 144. Bring down the X square. 81 plus 144 is 225. Last step, as you know, when we have X square, we square root the square root. We are doing it to both sides. The square root of 225 is 15, so X is going to be equal 15. My answer, X equal 15, is only true if it's down here. So this is the self-check part we're going to go through. By the way, the answer for 15 right here could be a little bit quicker if you look at the tip again. It said 3, 4, 5. If I multiply by 3 to 3, what do I get?
If I multiply the same common factor to 4 and 5, what do I get? 12? 3 times 5, 15. That is a trick. We will show you the long work here and then the trick.
Instead of doing it in order, I'm going to pick one of these which I think might throw you guys off, especially with the square root. So I'm going to go ahead and solve the letter N problem next. And I'm going to call that C the letter X. We have the side with 5 square root of 3 and 5. I put in X square equal 5 square plus 5 square root of 3. I forgot the square the whole thing. So I'm going to add one more parenthesis outside so that we're raising everything inside to the second power. Now let's go ahead and simplify. X squared, I'm going to go ahead and bring that down. 5 squared is 5 times 5, I get 25. And then this whole terms in here raised to the second power mean that I multiply that by itself.
Square root of 3 times itself, which is 5, times square root of 3.
To do is you're going to multiply the number here, and I get 5 times 5, which is going to give me 25. The square root of 3, when we multiply it together, we will get square root of 9. Or if you see that we have perfect square under the square root of 9 is 3, I'm going to go ahead and multiply 25 times 3. 3 times 5 is 15, hold 1. 3 times 2 is 6, with 1 is 7. Go ahead and add 25 plus 75. We will get on the right hand side, 5 plus 5 is 10, hold 1. 7 plus 2 is 9, with the 1 is going to be 100. X squared equal 100. We square root both, and I can get my x to be by itself after I take the square root of x squared. The square and the square root cancel each other out. I will end up with just x. Square root of 100 is 10 times 10, so my answer here is going to be 10. It is the answer when we have it down here on the decoding part, so let's check that. Oh, I see 10 right here. You are going to move on working on these problems just like how I show you with these problems here. Make sure that you can decode this message and you can spell it correctly.